Start. Good afternoon, everyone. Our topic for today is all about definition of terms. So, bago tayo mag-proceed sa problem solving in Thermodynamics 2, mag-start muna tayo sa definition of terms. First on our list is saturation temperature. Is the temperature at which liquids start to boil or the temperature at which vapors begin to condense. The saturation temperature is directly proportional to the pressure. So kapag sinabi natin saturation temperature, in terms of liquid, ito yung temperature kung saan magsisimula na siyang kumulo. Or kapag vapor naman, ito yung temperature kung saan start na siya na mag-condense. So, pinakamadaling salita, kapag sinabi nating saturation or saturation temperature, the pressure is directly proportional to the temperature. So, kapag sinabi sa problem, saturated yung temperature natin, titingin ka sa table 1 ng steam table. Kapag sinabing saturated pressure, table 2. So, ganun lang yan. So, example tayo. So, water boils at 100 degrees Celsius at atmospheric condition. So, atmospheric condition natin is 101.325 kilopascal. So, kapag chinek natin siya sa ating steam table, so ang given natin is yung sakto is temperature, di ba? Sa table 1 tayo titingin. So, table 1. So, ito yung temperature, di ba, nasa left side. So, 100 degrees Celsius, ang pressure niya is 101.35. Naka-MPa kasi to. Ayan. Kilopascal yung di ba, given natin. So, sa steam table, naka-MPa siya. Eta times 10 raised to 3 mo lang siya. Or, iusod mo lang siya ng 3. Kaya, 101.35. So, ibig sabihin, kapag equal yung temperature at pressure or directly proportional sila, saturated ang tawag doon. Another example, water boils at 179.91 degrees Celsius at a pressure of 1,000 kilopascal. So, kapag magbabasa ka ng steam table, yung kukunin mong value is yung eksakto. So, yung temperature mo kasi dito is may butal, di ba? So, kapag tinignan mo kasi yung steam table, yung temperature natin, puro sakto lang. So, doon ka titingin sa pressure. So, 1,000 kilopascal. So, kapag pressure or saturation pressure, table 2 tayo. Okay? Table 2, ayan, saturation pressure. So, naka-MPa to, i-convert mo to sa MPa. So, magiging 1 MPa siya. Right? Sa conversion natin. So, hanapin natin yung 1 MPa. So, ito, 1 MPa is equal to 179.91 degrees Celsius. So, ibig sabihin, saturated yung ating temperature. Or saturated yung ating pressure. Parehas lang naman. Next, steam condenses at 311.06 degrees Celsius at 10 megapascal. So, alin yung eksakto dyan? Yung pressure. So, sa table 2 tayo titingin. So, pressure. Ilan? 10 megapascal. So, ito 10 megapascal, 311.06 degrees Celsius. So, kapag sinabing saturated, ang tatandaan nyo lang dyan, the temperature is directly proportional to the pressure. Next. So, subcooled liquid is one which has a temperature lower than the saturation temperature corresponding to the existing pressure. Like for example, kapag sinabi nating subcooled liquid, yung temperature niya is lower than dun sa usual temperature. Like for example, yung kanina natin, di ba? Kapag 101.325 kilopascal, ang temperature niya dapat is 100 degrees Celsius. Pero yung liquid water natin is at 60 degrees Celsius. Therefore, subcooled siya. Okay? So, kapag ang temperature ay less than doon sa usual temperature niya sa steam table, tawag doon subcooled liquid. Dapat ito 100 degrees. Pero ang given natin 60, kaya subcooled ang tawag. So, kapag sinabi natin compressed liquid is one which has a pressure higher than saturation pressure corresponding to the existing pressure. So, kapag sinabi naman natin compressed liquid, sa pressure ka naman titingin. Yung pressure niya is mas malaki doon sa saturation. Like for example, yung 100 degrees Celsius, ilan dapat ang pressure niya? 101.325. Pero ang given natin dito is 110 kPa and 100 degrees Celsius. So, ibig sabihin, compressed liquid siya. Okay? Kasi yung pressure niya is mas malaki kaysa dun sa saturation na pressure, which is 101.325. So, yun ang kaibahan ng dalawa. Kapag subcooled, sa temperature ka titingin, yung temperature is lower than the saturation temperature. Kapag compressed liquid, yung pressure mas mataas kaysa doon sa actual or sa saturation pressure. Then, saturated liquid is a liquid at saturations which has temperature equal to the boiling point corresponding to the existing pressure. It is pure liquid and has no vapor content. So, basta may mabasa kayong terms na saturated, ang ano lang yan, ang definition lang yan, the pressure is directly proportional to the temperature. So, sinama ko lang tong terms na to kasi may bago siyang katangian. Kapag sinabing saturated liquid, it is pure liquid and has no vapor content. Kasi minsan lumalabas din sa board yan. Okay? So, sa elements. Then, vapor, kapag sinabi nating vapor, is the name given to a gaseous phase that is in contact with the liquid phase. Okay? So, self-explanatory naman yan. Then, saturated vapor is a vapor at saturation conditions. It is 100% vapor, has no liquid or moisture content. Kapag sinabi natin saturated vapor, parang yung kanina, saturated liquid. Ito naman, ang kaibahan niya doon is, it is 100% vapor and no liquid or moisture content. Then, yun nga, kapag saturated, the temperature is directly proportional to the temperature. Tama ba? Tama ba yung sabi ko? The pressure is directly proportional to the temperature. Ayan. So, example, steam at 212.42 degrees Celsius and 2 megapascal. So, check natin yung steam natin. Ilan yun? 2 megapascal. So, sa table 2 ka titingin kasi ang eksakto mo na value is pressure. 2 megapascal. So, ito yan. 212.42 degrees Celsius. Then, steam at 352.37 degrees Celsius and 17 megapascal. So, table 2 ulit. Check natin kung tama. Kung saturated ba siya. 352.37. So, ibig sabihin, itong dalawang conditions na to ay saturated vapor. Then, kapag sinabi naman nating superheated vapor is a vapor having a temperature higher than the saturation temperature corresponding to the existing pressure. So, kapag sinabi nating superheated vapor, yung temperature niya is higher than doon sa saturated temperature. Like for example, steam at 200 degrees Celsius and 101.325. So, alam naman natin na ang temperature sa 101.325 is 100 degrees Celsius. Therefore, mas mataas yung kanyang temperature. Therefore, ang tawag sa kanya ay superheated. Okay? Another example, steam at 300 degrees Celsius and 5 megapascal. So, check natin yung, ito, yung 5 megapascal sa steam table. So, kapag 5 megapascal, 263.99. So, mas malaki yung given natin. Mas malaki yung temperature niya kaysa dun sa saturation. Therefore, superheated vapor at tawag doon. Then, degrees of superheated is the difference between the actual temperature of superheated and the saturation temperature for existing pressure. So, kapag sinabi natin degrees of superheated, so, kino-compute natin dito kung ilan yung tinaas na temperature niya doon sa saturation temperature. Okay? So, ang formula niyan is T given minus T saturation, where the degree SH is degrees superheated. Yan yung temperature na difference between doon sa dalawa. Tsat is the saturation temperature and T given is the temperature given. Like yung diniscuss ko kanina, di ba? So, para makuha mo yung degree superheat, yung T given, which is 300 degrees Celsius, ima-minus mo lang dun sa saturation, which is 263.99 degrees Celsius. So, i-minus mo lang yung dalawa, makukuha mo na yung superheat. So, ganyan yung degree superheat natin. Okay? So, example. Okay, example pala. So, example, determine the degree superheat of superheated steam at 200 degrees Celsius and 101.325 kilopascal. Then, from steam table, alam naman natin na 101.325 kilopascal is equals to 100 degrees Celsius. Pero ang given natin is 200 degrees Celsius. Therefore, degree superheat is equal to T given minus Tsat. Yung given natin is 200. Yung Tsat natin ng 101.325 is 100 na nanggaling sa steam table. So, therefore, degree superheat is equal to 200 minus 100 degrees Celsius. Degree superheat is 100 degrees Celsius. So, nag-superheat yung steam natin ng 100 degrees Celsius. Okay? So, ganyan lang siya. Very basic lang. Then, next, degrees subcooled. So, ito naman, kabaliktaran naman siya ng degrees superheat is the difference between the saturation temperature for the given pressure and the actual subcooled liquid temperature. So, ito naman ginagamit siya kapag yung T given natin is mas malamig kaysa dun sa Tsat. Kaya ang formula niya, Tsat minus T given. So, example tayo. So, determine the degrees subcooled of liquid water at 90 degrees Celsius and 101.325. Madali lang kasi coming from steam table at 101.325, ang temperature niya is 100 degrees Celsius dapat. Okay? So, ang given natin is 90 degrees. Ang Tsat natin ay 100 degrees Celsius. Therefore, degree subcooled is equal to Tsat minus T given. So, Tsat natin ng 101 is 100 degrees Celsius. And yung given natin is 90 degrees Celsius. Therefore, degree subcooled is equals to 10 degrees Celsius. Okay. Then, wet vapor is a combination of saturated vapor and saturated liquid. So, kung titingnan natin siya sa steam table, yung lahat ng Fg dyan, ayan, di ba? Yung volume, walang Fg yan eh. F at G lang ang meron dyan. Internal energy, enthalpy, entropy, lahat yan, merong Fg. So, ayan yan. Fg, UFG, HFG, tsaka SFG. Okay, so, kapag sinabi natin wet vapor, Fg yun, ito yun, mga wet vapor yan. UFG, HFG, and SFG. So, nasa gitna yan. So, nasa gitna yan ng ating TS diagram. So, next lesson ko pa mapapakita yung TS diagram natin. More on definition of terms lang muna tayo, okay? So, yun. Combination of saturated vapor and saturated liquid. Then, quality, X. So, kapag sinabi nating X sa Thermo 2, yan yung dryness na tinatawag. The quality of wet vapor or wet steam is percent by weight that is saturated vapor. So, kapag tinanong sa sa exam yung dryness ng vapor natin, quality or X ang tawag doon. Kapag moisture ng vapor natin, ang tawag doon ay Y or wetness. The percent moisture of the wet vapor is the percent by weight that is saturated liquid. Okay? So, meron tayong formula of X over mass ng mg over mt. So, mass ng vapor divided by mass total. Ano ba yung mass total natin? Mass of vapor plus mass ng liquid. So, for saturated vapor, X natin or yung dryness is 100%. Yung wetness natin is 0%. Diba? Sabi ko kanina, saturated vapor, no moisture content. Kaya Y is equal to 0%. So, ayan. Formula number 3. So, paki-memorize to. So, kapag hinahanap naman yung percent moisture or yung wetness ng liquid natin, ang formula niyan is Y is equal to ml over mg plus ml. So, mass ng liquid divided by mass ng vapor plus mass ng liquid. So, for saturated liquid, gaya sa definition natin kanina, baliktad naman, Y is equal to 100 and X is equal to 0%. So, wala siyang 100% yung kanyang moisture content kapag sinabing saturated liquid. Then, yung dryness is 0. So, ayan. So, ayan yung kaibahan ng dalawa. Kapag X is dryness, then Y is wetness. So, ma-encounter natin yan sa mga sample problems. Mas lalo natin silang maiintindihan. The next definition is the latent heat of vaporization is the amount of heat added to remove from is the amount of heat added to or removed from the substance in order to convert it from saturated liquid or saturated vapor to saturated vapor or saturated liquid with the temperature remaining constant. So, ibig sabihin lang ng latent heat of temperature, ito yung amount ng heat mo na kakailanganin para ma-convert mo yung liquid into vapor or vapor into liquid. Without compromising the temperature. So, yung temperature mo remains constant. Okay? Then, critical point, it represent the highest pressure and the highest temperature at which liquid and vapor can coexist in equilibrium. So, kapag sinabi natin critical point, ito na yung pinaka-maximum na temperature and pressure natin sa ating steam table. Kung mapapansin natin, Tmax natin ay 374 degrees Celsius. Kapag tinignan natin sa steam table, doon tayo sa table 1. Ayan. Table 1 to, diba? Ayan, table 1. Kung mapapansin nyo, ayan, temperature to. Diba? Kung mapapansin nyo, pinakadulong temperature niya is 374.136 degrees Celsius. Ayan. Pinakasakto, 374.176 degrees Celsius. Yung pressure naman niya is 22.09. So, ito na yung pinaka-maximum na temperature and pressure na pwedeng ito na yung pinaka-maximum na temperature and pressure natin sa steam table na pwede nilang ma-acquire, okay, ng ating steam. So 374 degrees Celsius and 22.09 megapascal. Then sensible heat, heat that causes changes in the temperature without a change in phase. So mamaya i-discuss ko to. So kapag sinabi natin sensible heat, nagbabago yung temperature pero yung phase niya hindi nagbabago. Kabaliktaran naman siya ng latent heat. Kapag sinabi natin latent heat, heat that causes change in phase without damage in temperature. So ibig sabihin, kapag latent heat, nagbabago yung phase, pero yung temperature niya hindi nababago. Okay? So, example natin. So, para maintindihan natin yung kaibahan ng dalawa, so, mag-example tayo. Ice at negative 10 degrees Celsius to steam at 110 degrees Celsius. So, convert natin yung ice at negative 10 degrees Celsius into steam para ma-elaborate natin tong dalawa. So, let's say, eto, meron tayong ice. Kapag yung ice kinonvert mo sa steam, hindi naman agad-agad yan, di ba? Hindi naman agad-agad mako-convert mo siya sa steam. So, maraming process yung dadaanan niya. So, magiging tubig muna yan, then magbo-boil, tsaka siya magiging steam. Okay? So, from ice, negative 10 degrees Celsius, bababa muna yung temperature niya into 0 degrees Celsius. Hindi agad magiging tubig yan. Okay? So, nagbago yung temperature without changing phase, yellow pa rin siya. Tawag dyan is sensible heat. Okay? Then, kapag naging 0 degrees Celsius na siya, pwede na siyang ma-convert into water at 100 degrees Celsius. So, ang tawag naman dyan is latent heat. So, latent heat, mali yung diagram. Dapat, muna to. Pwede ba yung drawing na lang? So, ganito na lang. Dito na lang siguro. So, ang given natin, mali yung diagram yata. So, negative 10 degrees Celsius to 110 degrees Celsius na steam. So, from ice to steam. So, kapag magko-convert ka ng ganyan, medyo magastos yan. Maraming energy yung kailangan mo. Kaya, advisable, kapag maggagawa ka ng steam, dapat magsisimula sa water, hindi sa ice. Kasi, magastos yan sa energy. Sa fuel, ganun. Okay? So, negative 10 degrees Celsius. So, magsisimula ka muna sa ice, di ba? So, negative 10 degrees Celsius. So, ice. Diba? So, hindi naman agad-agad yan magiging tubig. So, magiging 0 degrees Celsius muna yan. Oh my God. Mali. Ayan. So from negative 10 degrees Celsius, magiging 0 degrees Celsius muna yan. So, ice pa rin yan. So, nagbago yung kanyang temperature, pero yung kanyang phase, hindi nagbago kasi parehas ice pa rin. Ang tawag yan is sensible heat. Then, from ice, magiging tubig na yan. So, kapag naging tubig yan, hindi magbabago muna yung temperature niyan. So, magiging 0 degrees Celsius pero tubig. Ang tawag naman dyan is latent heat. Ayan, mali yung diagram kanina. Then, after yan, kapag naging tubig na yan, pwede na yan mag-start na kumulo. So, tubig pa rin yan, pero na-reach na niya yung boiling point na 100 degrees Celsius. Therefore, same pace, pero yung temperature na bago, ang tawag dyan ay sensible heat. Okay? Then, from 100 degrees Celsius, ayun, pwede mo na siyang i-convert into steam. Diba, yung steam kaya niya hanggang kapag ordinary na kapag ordinary na ordinary lang yung papakulaan, yung for example yung yung takore, diba? Pwede siya umabot hanggang 110 degrees Celsius, diba? So, from 100 degrees Celsius, kapag naging steam na siya, steam, hirap magsulat ayan. So, same lang din kanina from nung ice tsaka sa water, kapag na-convert siya, nag-change phase, hindi mababago yung temperature niya. So, 100 degrees Celsius pa rin yan, steam. So, from water to steam, ang tawag dyan is latent heat. Then, kapag na-reach niya yung phase na steam, pa lang yan mag-reach ng 110 degrees Celsius. So, nabago yung temperature, ang tawag dyan is sensible heat. So, yun, yun lang yung kaibahan ng dalawa. Okay? So, kapag nabago yung temperature without changing phase, tawag dyan is sensible heat. Kapag nabago yung temperature kapag nabago yung phase without changing temperature, tawag dyan is latent heat. So, yun lang naman yung kaibahan ng dalawa. So, yun na. So, that's all. So, that's all for definition of terms. Next week, start na tayo ng problem solving.